lectures are remaining. So today, one of them, we had actually seen hybrid drivetrain design yesterday, last day, and in that we actually had been doing the parallel hybrid electric drivetrain design. Things are quite similar, fundamentals are quite similar. So since the second half of fourth chapter, we are doing actually the same things. All the things are very similar. There is nothing different in that. It is all about drivetrain design. It is series or parallel, and whenever it is parallel, we are finding that there are two things. And okay, first let me tell you the topics that we are going to do today. Same topics we had done in case of series hybrid as well. That is state of charge control and engine on off thermostat control. So first is state of charge control is called as PPS, and engine on off control is called as thermostat control. So we had done this block diagram long back. So let me first tell you again about what is meant by parallel hybrid electric drivetrain. So here you will be finding that there are two paths of power, or mechanical power rather, because this parallel hybrid electric drivetrain is called as mechanically coupled drivetrain. So here only mechanical energy is given to the final drive element. So from the engine, which is actually supplied by the fuel source. So fuel from fuel tank, fuel is coming to the engine. Engine is generating a mechanical output. Here the clutch is there. So after that, this is the primary transmission, and power is given to the torque. This is the first mechanical power or main electrical power output. And this torque is then given power to the main drive element for traction purpose, and wheels are driven. This is the first or main power source, mechanical power source. Then there is a second source, this peak power source. This is the PPS. So design of this PPS we will see today, control strategy of PPS. Now this PPS is giving power to the motor controller. Actually, motor controller is not mainly taking power, but it is actually mainly controlling the power. So after that, the power is given to the motor, and motor is again generating a mechanical torque. So this mechanical torque from motor, mechanical torque from the engine, both are coupled here in this torque coupler. So this is a mechanical coupler, which is the main coupling element for two sources. So this is one source, engine, which is for the base speed, and there is another source which is called as peak power source. So whenever there is a specific requirement or bumper requirement of power, at that time this peak power source or PPS is going to supply the power. This is mainly battery. Okay, so these two powers are getting added at the torque coupler, and it is being given to the final drivetrain. So this is actually called as parallel or mechanically coupled drivetrain. Now here, this is a vehicle controller who is accepting the inputs from the accelerator, from the brake, and from the steering, and from the speed, clutch. All these things are being accepted by the vehicle controller. And depending on the category, it is sending the signal to the different parts in the vehicle. So when speed is to be controlled, vehicle controller is asking engine controller, and engine controller is actually giving signal to the engine for the speed increment or for further acceleration. Whenever the acceleration is happening, how much acceleration has happened, to know that there is a vehicle speed sensor here. Okay, it is connected to the axle, or maybe it is connected to the wheel. So from there is a feedback. So this feedback is coming to the vehicle controller and telling that this much is the vehicle speed in meter per second. At the same time, whatever is the speed of the rotational speed of the engine, so it is an RPM. So here there is the engine control signal from the vehicle controller to the engine controller, and whatever is the rotational speed of the engine in RPM, that is again feedback to the vehicle controller. So these are the two speed feedbacks with which vehicle controller is coming to know whether the engine is running perfectly or whether the vehicle is running with required speed. So these two are the feedbacks. There are more feedbacks, that is from the peak power source. So this PPS is nothing but a battery which is supplying the energy when the vehicle is trying to go uphill, or whenever it is in an off drive kind of a drive kind of a thing, like the vehicle is passing through a hill or jungle or maybe desert. In those cases, this peak power source will be supplying the energy to the vehicle. So in this parallel path, second parallel path is coming in more use in those cases off-road driving. On-road highway driving, this engine is giving sufficient power. Now this peak power source, how much is the SOC, that is state of charge uh, that thing is sensed by SOC sensor, and it is given to the vehicle controller. Vehicle controller is also giving the command to the motor controller for how much power is being given to the final motor. That is a secondary transmission output to know that this vehicle controller is actually giving the control signal to the motor controller and this motor. So you have done embedded system, so all these things are known to you. I'm just telling you how many control signals are there. So there are these two feedback signals. There is another feedback signal, that is how much is the charge in PPS, and there is a command signal. So how many command signals are there? One is engine command, engine control command, one is motor controller command, another is mechanical brake control. So there are actually two brakes here in this system. One is mechanical brake, one is electrical brake. In the electrical brake, actually we are controlling this motor which is connected to the PPS. So this motor is actually generating the traction power, as well as during regenerative braking, this motor is acting as a generator and sending the power back. So two motor controller, one is called as PMB. So this is called as mechanical brake, another is called as PMF. We will see all those things in the latter stages. So these are the two mechanical controllers. So this brake is given to the this tire, brake is given to another tire. So these are the brake signals which are given to the different tires. Now let us see what are the different control systems related to it. So here the engine supplies its power to meet the base load. So base load is provided by the engine operating at a constant speed on a flat mild grade road, or the average of the load to stop and go driving pattern. So that is a base load which is being supplied by the engine. And the electric motor supplies the bumper power to meet the peak load demand. So I told you, if the vehicle is going uphill, at that time there is a peak load demand that will be supplied by this PPS source. Control system of the vehicle drivetrain consists of vehicle controller. So this is the first thing, an engine controller. So I'm reading from here. An engine controller which is mainly controlling the engine, an electric motor controller. So this is the electric motor controller. So this engine controller and electric motor controller, they are the main control element for the mechanical power to the output. And a mechanical brake controller. So at the top, this is the mechanical brake controller, and a clutch controller. So clutch controller is coming just after the engine. So these are the different controllers which is coming, and there are different links. One is called as mechanical operation. These are the mechanical connection link at the output also. Electrical connection. So from the PPS to motor controller to motor, this is the only electrical controller, and signal. So there are many signals here in this case. You can see. Now this is not the main thing that we are going to do. This is called as configuration of parallel hybrid torque coupled drivetrain. So these are the questions for exam. So now these are the four sources. So this is the PM. Now you have to remember all these things because we are going to go for the next topic, that is a PPS control. So there all these elements will be required. P is the engine power, PL is the load power which is required for the vehicle to be driven. PM is the motor power, and PPSC or PMC. PPSC or PMC is the PPS charging or a motor charging power. So whenever I am saying motor, this motor is actually driven by this PPS, peak power source. So it is called PPSC or PMC. So this PPSC, PMC, PM, PL. So these four are the main power for driving or traction of the motor element. Now there are coming two brakes. One is called as mechanical brake, which is called as PMF. Initially I told it PMB. PMB is coming here. This is called as motor brake power. That means how to stop this motor. Okay, so this is electrical braking, and this mechanical brake power, this is called as mechanical braking. So these are the elements, or these are the symbols that you have to remember. Now I have already explained this thing to you long back, but as we are doing this thing almost after 1 week, I had given you this explanation, and now I'll be going for the main topic. So few people have left this meet already. I am finding they thought again the same thing is being explained. So I was actually explaining the thing for your purpose, because you might have forgotten this diagram. So now I'll go for the main topic for today, which is called as maximum SOC of PPS control strategy. That means whatever battery is there, that should always be storing or keeping maximum charge, so that whenever there is a bumper demand, this battery should be able to sustain or should satisfy this bumper power demand. How to control that? So that is actually being explained in the next slides. So this slide was also explained to you, these two slides, this one and next one, but again I'll be doing it because we are doing it for after a long time. So when a vehicle is operating in a stop and go driving pattern within the city, that means there is too much stopping and there is too much braking and all these things. So the PPS must deliver its power to the drivetrain frequently. Consequently, the PPS tends to discharge quickly. So either in a hill or in an off-road or within the city when there is stop go kind of arrangement, PPS continuously supplies the power, delivers the power, and PPS discharges quickly. But in this case, we have to maintain a predefined PPS power level that is always there. Your bumper source power should always be satisfied. So in this case, maintaining a high SOC in the PPS is necessary to ensure that the PPS can deliver sufficient power to the drivetrain to support the vehicle frequent acceleration. So whenever the vehicle is maybe on the highway or maybe on the hill, it wants to accelerate, that extra power is supported by the PPS. Basic rules in control strategy are using the engine as the primary power source as much as possible. So engine should be always the base power source as much as possible, and we should use the PPS as less as possible. Whenever there is extreme need, then only we should use the PPS. Otherwise, all the power should be supplied by the main power source, that is the engine only. So the strategy is engine primary power source should be used as much as possible and charging the PPS whenever the engine has excess power over the required for propulsion. Now propulsion power is given by PL. If you see the previous slide, this PL is the propulsion power. Now this PE is actually satisfying the PL. Now suppose I am saying PE is 100 units, PL is 80 units. So where does this 20 unit go? This 20 unit will be used to charge this PPS. So main aim is that PE should be almost equal to PL. That means this engine should be always driving the vehicle. That is the main agenda. But sometime if power required to drive the car or vehicle is kind of comparatively low because you are on highway, there is very good quality road and all these things. In this case, this tractive power required is very small. Okay, so in this case, if 100 unit is produced, 80 unit is used to drive the car. So remaining 20 units will be charging the PPS. So actually you have to steal some power to charge the PPS always, and that is the strategy. So PPS, whenever the engine has excess power over that required for propulsion, that means P greater than PL, without the PPS SOC exceeding its full charge limit. How far we should charge the PPS? Till the PPS is reaching to 100%. Whenever the PPS is reaching to 100%, then all the 100 units power which is produced from the engine should be given to drive the vehicle only. So PE in that time will be PL. So this is the main control strategy. This is the third sentence. Remember it properly. So in this control strategy, which is called as SOC of PPS control strategy, the maximum power curves for hybrid traction. Hybrid traction is engine and PPS together. So that is actually hybrid traction. In this control strategy, the maximum power curves for hybrid traction, engine alone traction. So these are different names. Hybrid traction means engine plus electric motor together. That means engine and PPS together. Engine alone traction. That means only PE is driving the PL. Electric motor alone traction. That means PPPS is equal to PL. And regenerative braking are plotted against vehicle speed. So these are the main four cases. Two more cases are shown. So there are total 6 cases that we have to study. So main four is here. So this main four we had found in case of series hybrid electric vehicle also. But for parallel hybrid electric vehicle, there are 6 strategies. So these two questions are very important questions for exam. SOC PPS for series hybrid, SOC PPS for parallel hybrid. If you see the question bank which is given, so complete question bank is uploaded. There also you will be finding that both these questions are asked. And both these questions can be asked as a 5 marks question as well. So in one question I can ask you explain series hybrid PPS as well as explain parallel hybrid PPS. So in series hybrid there are 4 strategies, in parallel hybrid there are 6 strategies. So main control strategy in parallel hybrid is hybrid action, that is engine and motor together, engine alone, motor alone, and regenerative braking. And in braking, there are actually 2 types. One is regenerative braking, that is only electrical braking, and one is extreme braking, that is electric and mechanical braking together. So we have seen that during series hybrid. So all this we will see after this slide. So power demands in different conditions are also plotted in the next graph. So they are given as point A, B, C, D, E, F. So there are there are 4 points only, A, B, C, D. Operation modes of the drivetrain are explained as follows. So you can see here in the left side. So this diagram I will be repeating in every slide. And you have to explain that. It looks quite critical, but it is not difficult. And try to replicate as much possible this diagram. A few points if you leave, that also is okay. But if you understand this diagram while explaining, all these things automatically will come. So there are mainly six propelling mode. So first one is motor alone propelling mode. Which one is motor alone propelling mode? You are finding this one. Okay, so this point A is motor alone propelling mode. Then there is hybrid. Sorry, let us see which one is that. Then there is hybrid propelling mode, PPS charging mode. Okay, so this thing PPS can get charged either through the engine, or PPS can get charged during regenerative braking. Engine alone propelling mode, that means PE is equal to PL. Regenerative alone brake mode and hybrid brake mode. So you are finding there are four brake mode. In regenerative alone brake mode, whatever is the braking, it is being produced by the electric braking. So whatever is the electric motor is there, that will go into brake fashion and that will produce this regenerative braking. In hybrid braking, whenever the word hybrid is coming, it is mechanical plus electrical. So in hybrid braking, we will be finding mechanical and electrical together. They are actually putting the braking function. So these two are the braking, and above four are the actually above three are the propelling, and this is a PPS charging mode. So this is not about propelling the vehicle. So if you categorize the six, you will be finding there are mainly three propelling mode. One is engine based propelling mode, one is motor based propelling mode, and one is hybrid propelling mode. So very easily you can remember this. So there are only two propellers, one is PPS, one is engine. So when the PPS is driving the vehicle, it is called motor alone propelling mode. Propelling means traction, it is taking the vehicle forward. When the engine is propelling the vehicle, it is called as engine alone propelling mode. And third one is the hybrid propelling mode, where engine and motor or PPS together, they are taking the vehicle forward. So these three are the propelling modes. One mode is the PPS charging mode. So here the PPS is getting charged. Now it can get charged either through engine or through regenerative braking. But in this case, PPS charging means it is getting charged through engine only. Then there is coming to braking modes. So one is regenerative braking. Here only the electrical braking is applied. And one is hybrid braking. Here electrical and mechanical both brakes are applied. So every case I will be giving you some equations, and every case you have to find how to write it. So very small paragraphs are given. In exam also you have to write like this. In book also the same thing you will find. So if you are preparing all these things from my slide, that will be sufficient. So first one is motor alone propelling mode. So where is the motor? Again you have to go back to the previous slide. This motor. Okay, so this motor is actually getting power from the PPS. So motor alone propelling mode means only PPS is given power to the motor is given power to the torque coupler, and it is driving the whole vehicle system. Engine alone driving system means PE is giving power to the torque coupler and engine is driving. So P is equal to PL. Hybrid means PPS plus PE is equal to PL. So these are the three cases of propelling mode. It's very easy to understand. So first one is motor alone propelling mode, but there are certain other parameters that you have to explain. So there are five curves which are shown: 1, 2, 3, 4, 5. So here is a vehicle base speed, and if you are going in the positive direction, this is the traction power. That means I am actually pushing the vehicle forward by using traction power. And whenever vehicle speed is below the base speed, so VEB is called as the base speed. Okay, if you are actually driving the vehicle with speed below the VEB, actually that time braking is generated. So C and D, these two are the braking. In case of C, so first, actually I will explain the top part first. That will be better, because the C and D will be explained last. These are the two brakings. Yes, in the first case, motor alone propelling mode, which one is that? So VEB, VEB is very important thing. So if the vehicle speed is less than the preset value VEB, which is the lowest vehicle speed, very important thing. VEB is the lowest vehicle speed because there is a baseline. Okay, so there is a vehicle speed, lowest vehicle speed. The vehicle operates with high fuel consumption and with high emission. Lowest fuel speed means lowest vehicle speed means whatever is the opposition offered to the vehicle, that is almost equal to whatever is the traction power generated by the vehicle. So whatever power vehicle is generating to go forward, and whatever power is coming onto the vehicle in the reverse direction, if they are same, so vehicle just goes forward. That means it cannot accelerate. It is somehow maintaining a very base speed, which is called as VEB, which is the lowest vehicle speed. So in this case, vehicle is eating a lot of fuel, because it is taking quite a lot of fuel. It is trying to generate too much of power, but whatever power it is generating, all the power is going into the waste mode. So high emission is there. Emission is very high, because in that case, vehicle is not able to overcome the hurdle that is coming to it. So in this case, vehicle is just going forward. So that is here, we are somewhere here. So below this VEB speed, the engine cannot operate stably. So VEB is the, you can say, is the limiting speed. So if the vehicle speed is above VEB, then only you can say vehicle is going forward. Below the VEB speed, electric motor alone propels the vehicle. So below this, it is the electric motor propelled thing. Meanwhile, the engine is shut down or idles alone with the clutch open. So in this case, PE is not there. That is the first thing. Only PMC or PPS, that much power is there, which is coming from the PPS battery, which is driving the vehicle. The engine power, electric traction power, PPS discharge power can be written as. So these equations are very important. So it was shown here that engine is shut down. That means P engine is equal to 0. That is the first thing. PM is equal to PL. That means the vehicle load or vehicle, whatever is the demanded traction power, that is being supplied by the motor itself. That is coming from the PPS or the battery source. So P motor or mechanical motor is equal to PL. That means motor power is equal to propelling power, and PPPSD is equal to PM by eta m. So whatever PPS is there, that is actually supplying the power to the motor. But I say that if suppose motor power is 100 unit, so this 100 unit power is required to propel the overall vehicle, but engine motor is operating with 90% efficiency. So PPS has to produce more power. Okay, so PPS if is producing around 111 unit of power, so that 111 multiplied by zero point 0.9 is equal to 100. Or you can find out how much power PPS is producing. So PPS is producing whatever is the required power. Required power, let's say, is equal to 100 units. So 100 by zero point 0.9, it will be around 111. So if PPS produces 111 unit power, then only the motor will be producing 100 unit power at the output. So this is a very important equation. This you have to understand. So here, what are all these things? So this is the first slide. That's what I'm telling you all this thing again. So P is the engine power output. So P is the engine power output, which is 0, because in this case vehicle is running almost with VEB speed. So at VEB, PE is equal to 0. PL is the propelling power demanded by the driver from the accelerator pedal. So PL is the power required to drive the vehicle. Operator does not care from where the power will come, whether the power will come from engine or power will come from PPS source. He just demands it. Okay, and the vehicle controller has to see that this PL power is supplied by the either engine or PPS or motor, whatever. So PL is the power required to propel the vehicle. PM is the power output of the electric motor, and that PM power is coming from PPS. Okay, so PM, if it is working with motor efficiency of 90%, in that case PPS has to generate more power. So if a PL is asking for 100 unit power, PM has to give 100 unit power, but in that case PPS has to generate 111 units power. So this 111 unit is equal to 100 divided by zero point 0.9. Okay, so if you do 100 divided by zero point 0.9, so 100 is actually required power at the load or power given out by the motor. But to generate this 100 unit by the motor, which is working with a zero point 0.9 or 90% efficiency, PPS has to give 111 watt power. That means motor definitely will not be working with 100% efficiency. If motor is working with 100% efficiency, then this 11 units of wastage will not be there, and no motor can work with 100% efficiency. So as the motor is working with 90% efficiency, whatever power is being given by the PPS, some of the power will be wasted and the remaining power will go to the load. That is whatever is the power demanded by the driver. So this is a very important slide. Only thing you have to remember here, this is motor alone is driving the vehicle with a speed of VEB. Engine is not giving any power. So motor power is equal to load power, PM is equal to PL, and motor is being supplied by the PPS. So PPS has to produce power computing the motor efficiency into consideration. So if 100 watt power is required, PPS has to generate 111 watt. So if they say that okay, this engine efficiency is 80%, then this will be 125. So 125 divided by zero point 0.8 is equal to, sorry, 100 divided by zero point 0.8 is equal to 125. So lesser will be the efficiency, more will be the power that PPS has to produce. So this is the second type of, this is the first type of propelling mode. Now other things are comparatively easy. You have to be observant. So here I had blocked this red VEB. So this is a point to be remembered in this motor alone propelling mode. In the second case, it is called as hybrid propelling mode. You can see here number one case. So this is the hybrid propelling mode. Actually, it is said here maximum power in hybrid mode. This is the graph for the hybrid propelling mode. So here actually I am at point A. I'm at point A. So point A is the PL. So this much PL power is being demanded by the driver, PL power. So in that case, from 0 to this A, small a point, this much is the engine power, 0 to small a. This much power is produced by the engine, and remaining power from here to here, this much power is produced by the motor, which is called as PM. Here it is given PM is the motor traction power, and PE is the engine power, PL is the load power or traction or braking power. So all these things are quite clearly explained. So here the propelling power demanded by the driver is given by PL, which is represented by point A. So here there is point A, and point A is quite above than the VEB. So as demanded power is greater than the power produced by the engine E, because this much is the engine power PE, okay, and this much is the demanded power. So who is going to fulfill the remaining thing? The motor is going to fulfill the remaining thing. So here actually PPS and engine both are working together. So PL power needed by the drive wheel or drivetrain is supplied both by the engine and the electric motor together. So in this case, the engine operation is set at its optimum operation line point A. So this point A is actually the engine optimum line. So this line 3, you can see that engine power on its optimum operating line. You can see here this dark graph, okay, line 3. It is called as engine power on its optimum operating line. So engine can produce more than that, but this is optimum means engine is going to give maximum efficiency. Maximum efficiency is not equal to maximum output power. So engine can generate more power than this, but in that case efficiency will be reduced. So whenever there is a hybrid mode, we operate the engine at maximum fuel efficiency, and remaining power will be produced by the motor. Very important case. So in this case, the engine operation is set on its maximum operating line, that is point A. So this is the point A here. So this is the maximum operating line in this case. So PE is the engine power given. Controlling the engine throttle. So how can you control the operation up to point A? This can be controlled by engine throttle to produce power PE. The remaining power demand is supplied by the electric motor PM, the motor power output, and the PPS discharge power R. So in this case, this PM is always obtained from PPS. So that formula always states that PPS discharge is equal to PM by eta M. Here it is written, PM is the motor traction power, eta M is the motor efficiency, PL is the load power, P is the engine power, PM is the motor traction power. So these three are the powers. So top one is the demanded power, and P and PM are the power which is supplied to fulfill this PL. Whenever this PM is equal to PL, in that case we can say it is engine is stopped, motor driving alone. When this P is equal to PL, we can say that motor is stopped, engine driving alone. And in this case, hybrid propelling mode, PE and PM together, they are supplying the PL. So if you see here, you can find here that is PL is equal to PE plus PM. You can find here. So if you take this PE left side, so PE plus PM is equal to PL. So how much power should be motor giving? It is found from here. So motor should be given a demanded power minus engine power. And last one, this is a evergreen formula, that is PPS discharge is equal to PM divided by eta M. So how much power the PPS has to generate, that is equal to motor power by motor efficiency. Again, I told you that if PM is equal to 100 unit and PM is, that is the motor is actually working with 90% efficiency, in that case PPS discharge will be 111 unit. Okay, in that case only the PM will be 100 units, so that PM will be plugged here. And suppose PL is demanding 150 units, so PM produces 100 unit, PU will be producing remaining 50 units. So if you understand it with the help of some numerical, it will be easier for you. So this is how it is. So this is the best actually hybrid propelling mode, and all the things are explained kind of here. So everything above this VEB line is coming in this hybrid propelling mode, and this is the most important propelling mode because this is, we are talking about parallel hybrid. So this is actually parallel hybrid. Now I'll be going a little faster. So it is saying that PPS charge mode. So in this case, when the demanded propelling power PL represented by point B. So now we are here. So this is point B, and what is this? This is line number 4. So engine power with partial load. You can find here this fourth line, engine power with partial load. What is meant by that? That means whatever engine power is produced, that much power. I told you that if 100 watt is being produced by the engine, 80 watt is required by the PL. Where does this remaining 20 watt goes? It goes to charge the PPS. So this is that thing. PPS charge mode means when the demanded propelling power PL, which is represented by point B in the figure, is less than the power that the engine can produce while operation in its optimum operation line. So in this case, it means that PL is equal to, let's say, 80 units. PE is say 100 units. That means engine produces 100 unit power, and to drive the vehicle only 80 units are required. Where will the remaining 20 unit go? The remaining 20 unit will go to charge the PPS. So and the SOC is below, this SOC of the PPS is below the top line. So SOC of the PPS, so this is the SOC top line. Okay, so here it is below. Okay, that means SOC is not fully charged or PPS is not fully charged. So in that case, the engine is operated on its optimum operating line, point B. So point B is here. Okay, so below its operating line, engine is operating below its operating line. That means engine is in this dash lines. So in this case, producing power PE. That means engine is also not fully operated, not to the stretched limit, and vehicle is also not requiring too much power. That means PL is also less, and whatever power engine is producing, suppose 100 unit, only 80 units are required by the PL. So remaining 20 unit will go to the PPS. So here, in this case, the electric motor is controlled by the controller to function as a generator. So whatever power goes from engine to the PPS, it has to follow through that electric motor kind of a thing. So in that case, the electric motor acts as a generator. So it goes in reverse direction, and engine power actually charges. So I'll go to the slide again. Okay, so here you can see in this case, engine, whatever power given, so that power will come here. This motor will act as a generator, and the power will go back. Okay, so engine, when engine is charging PPS, what is the path? So engine, transmission, torque coupler. This motor acts as a generator, goes reverse, then through motor controller, power goes to the peak power source. So this is very important thing. This third case is very special case, when the PPS is charging by the engine. So very important lines written here, and the SOC of the PPS is below the top line. The engine is operated on its optimum operating line, point B, producing its power PE. So this is that point B at the top. So in this case, the electric motor is controlled by the controller to function as a generator, powered by the remaining power of the engine. The input power to the electric motor and the PPS charge power R. Okay, so PM is equal to P minus PL into eta TEM. This is actually the time dependent efficiency of the motor. So P minus PL, who is greater? P is greater. That means engine is actually producing more power than what is demanded by the load or demanded by the traction. So that much power is produced, and that much power multiplied by efficiency, because whenever I am mentioning PPPS and PM, there will be coming this eta factor, because whatever power PPPS is producing, that part is going to motor with the efficiency factor. So this much power is actually produced, which is charging the PPPS, but that is charging the PPPS through the PM. So that's why there is coming a eta TEM. What is eta TM? I'll tell you. And what is PPPSC? This is nothing but PMC, that is PM into eta M. So this PPPS is charged by PMC. PMC is given here is PPS charging power. PM is motor power, but PMC is the PPS charging power through the motor. So PPS is getting charged through the motor, and motor is acting as a generator. Hence, it is called as PMC. So where eta TEM is the transmission efficiency from the engine to the electric motor. Now engine to the electric motor, just see that engine to the electric motor, that means from the engine it is going to the torque coupler, again it is coming back to the electric motor, and then it is going to the PPS. So it's a reverse path from the output torque coupler to the PPS, and that efficiency is called as eta TEM. So it is the transmission efficiency from the engine to the electric motor. So it's a reverse path So the whole block diagram and functional diagram should be imprinted in your brain. Then only you can understand all these different things. So this is the B line. The B line is the maximum engine power line. But now we are at line 4 because 4 is engine power with partial load. In this case, this capital B is less than small b. Whenever the engine is working with small b kind of a thing, in that case engine is loaded partially, and in that case whatever power engine is producing, most of the thing is going for driving PL, and some part is fed back to the PPPS source to charge the PPPS. So this is also a very important part, PPPS charging the thing. This thing is very easy to understand. That is, when engine is propelling the vehicle alone. That means in this case we are actually will be finding that PPPS is zero. We are not taking any power from the PPPS. So when the demanded propelling power shown as point B is less than the power that the engine can produce while operating on its optimum operation line, and the SOC of the PPS has reached its top line. That means you had been doing this C part, you had been charging the PPPS, and the PPPS has reached to the top line. So PPPS is full now. Now whatever power the engine is producing, the whole power will go for driving the vehicle only. Because engine power is doing two things, driving the vehicle and charging the PPS. In the third stage, you have charged the PPS to the 100%. Now whatever engine power is produced, that will be only going to drive the vehicle. So in this case, you are finding P is equal to PL and PM is equal to PPS is equal to 0. So when the demanded propelling power shown at point B, this one, is less than the power that the engine can produce. Okay, so vehicle is itself is asking, chalo, only 80 watt power I want. So vehicle engine will produce only 80 watt. Previously, engine was producing 100 watt, vehicle was requiring 80 watt, and that 20 watt was going to charge the PPS. Now PPS is fully charged. Now vehicle is requiring 80 watt, engine only produce 80 watt, so it is not going to produce 100 watt now, because in that case it will be wastage of energy. So in this point B is less than the power of the engine can produce while operating on its optimum operating line, and the SOC and PPS has reached its top line. Previous case you just see, previous case what was written, and the SOC and PPS below its top line. So this is the only difference. So in the PPS charging, SOC and PPS is below the top line. In the next case, SOC and PPS has reached its top line. So in this case, SOC is also fully charged. Then engine alone propelling mode is used. Here, the electric system is off. That means PPPS system is off, motor is off. Engine is only power source for the load demand. Power output curve of the engine with a partial load is represented by the dashed line. So this B line. Engine power, electric power, and battery power can be expressed by. So P is equal to PL. Whatever is the engine power, that is equal to load power, and PM or PPS power is equal to 0, because PPS is fully charged. So PPS is 0 does not mean stored power is 0. PPS is 0 means no energy is going from PE to charge the PPS. So no reverse power is going to the battery to charge the PPS, because PPS is fully charged. Okay, so these are the four modes. These are the four modes. That is, first one is the PPS is actually driving. That means motor is driving the vehicle. Second one is hybrid. Third one is PPS charging, and fourth one is engine alone propelling mode. So these are mainly four propelling modes. Now we will enter regenerative alone brake mode. That is actually the point C. So in this case, you are finding that PL, this is actually the brake power which is demanded, and PMB here motor braking power. So in this case, the motor actually is generating the brake power. So in this case, actually you are operating the vehicle below the VEB speed. That means you are operating the vehicle below the base speed. That means actually vehicle is decelerating. So we are actually braking the vehicle. In this case, who is generating the braking power? It is MB, motor braking power. So I told you there are two types of braking. One is mechanical braking, one is motor based braking. So motor based braking is called as electrical braking. So in this case, the vehicle is at point C. So when the vehicle experiences braking and the demanded braking power is less than the maximum regenerative braking power that the electric system can supply, point C. So this point D is actually the maximum braking power. Okay, so D is the maximum braking power, but C you are finding that brake power is less. That means not too much deceleration. Deceleration is there, but not too much deceleration. In this case, we are at point C. The electric motor is controlled to function as generator to produce the braking power, which equals the demanded braking power. So in this case, two things happen. the vehicle is getting decelerated, and whatever is the regenerative braking happening, that is actually charging the PPS, because the motor is acting as a generator. So in this case the engine is shut down or set idling, because anyway power demanded is very low, vehicle is decelerating, so engine does not need to produce any power because vehicle is decelerating now. PL is very less in this case. So the electric power output from the motor and the PPS charging power is, so PMB is equal to PL into eta M. So whatever power is produced by the, whatever power is demanded, actually that thing is used in a braking. So how much is the braking power? PMB is equal to PL into eta M. Okay, so whatever power is required by the PL, that is for the loading, multiplying that by some efficiency, let's say zero point 0.9 or something, so PMB is there. So with less amount of power you can do the braking. And second one is PPPS is equal to PMB. So whatever is the braking power applied, this PMB, that is actually will go to the PPPSC. Previously we had seen PPPSD when the electric motor was driving the vehicle. PPSD means at that time PPS was supplying the power to the PL. In this case actually PL is supplying the power back to charge the PPPS. That means PPS is getting charged here. So that's why this is called as regenerative braking. And whatever mechanical electrical brake I'm applying, PMB, that is actually charging the PPPS. So this we have seen in the DC chopper kind of a thing, second quadrant operation. There while the vehicle was under braking, it was actually sending some power back to the PPPS. So this is a very okay. So fifth one was regenerative along brake mode. Now we are going to find this the last one. It is called as hybrid brake mode. So when the demanded brake power is very big. Okay. So previously demanded brake power was small. Only the electrical motor type of braking was doing the braking thing. But in this case, in point D, in this case, brake power required is too much. That means there will be two kind of brake which will come into picture. One is the PMB, that is the motor brake power. Motor brake power in this case is too much, maximum motor brake power. So this is the maximum regenerative braking that the electric motor can produce, plus PMF. So PMB is the maximum electrical braking the motor can produce, and PMF is the mechanical brake. So in the first, that is the parallel hybrid block diagram I had shown you, there are two kinds of brake. One was the mechanical brake, another was the electrical brake. So electrical brake was being produced by the motor which was connected in the PPS side. So that motor and mechanical brake together, they are producing the hybrid brake. So this F is actually the hybrid brake mode when the demanded braking power is greater than the maximum regenerative braking power. So this PMB max here. Okay, so PMB max here, but actual required braking power is greater than that. That means suddenly too much brake power we have to apply. So electrical and mechanical together, electrical system can supply, mechanical brake must be applied. So here the electric motor should be controlled to produce the maximum regenerative braking power. So PMB is maximum here. In the previous case, PMB was not maximum, PMB was less, so PL was equal to PMB. In this case, PL, that is required power for braking, is equal to PMB plus PMF. So here the mechanical brake system handles the remaining portion of the power, the motor output power, PPS charging power, mechanical braking power R. So whenever PMB is there, there will be a PPS charging. This you can understand. Whenever there is a electrical braking, PMB, at that time there will be a PPPSC. It will always be there. So in this case, you are finding PMB is equal to PMB max eta M, and PPPSC is equal to PMB. So always whatever is the mechanical brake power, that will go and charge the PPS. And finally, PL is equal to PPPS plus PMF. So PPPS is nothing but PMB. So you can say that PMB plus PMF is equal to PL. In this case, PL is not the traction. In this case, PL is for braking. So PPPS is nothing but PMB. So you can say PMB plus PMF is equal to PL. That equation also can be written. So in this case, whatever is the total power for braking, that is PL is required. PMB is supplying some, that is electrical braking, and remaining power is coming from PMF, and PMF is nothing but mechanical brake power. So these are the 6 types of operating modes for a parallel hybrid electric drivetrain. In the exam, you have to explain all the 6 together, and for this, these graphs are very much important. So there is nothing difficult, only if you understand all the 6 modes, you'll be able to explain it very properly. So here are the flow charts for SOC of PPS. So first, traction power and all these things are expected from the driver. So whatever is the acceleration or deceleration or a brake, all those arrangements are asked from here. So whether you are asking for traction power or you are asking for braking power. So if it is traction, you have to come below. If it is braking, you have to come in this. So E and F. So last thing. So E was the regenerative braking, F was the hybrid braking. So PBC is greater than PM max. That means whether the braking power is greater than or equal to maximum power. So if you are finding that too much of motor power is required, maximum motor power is required, that means actually you are going for hybrid braking like this. And if less than motor power is required, that means only the motor power will be supplying the brake power. In that case, only regenerative braking, that is electrical braking, will do the job. So in this case, hybrid braking, it is mechanical plus electrical. In this E case, it is only electrical. So maximum motor power, which is also coming to the vehicle. So PBC, whether it is greater than PM max. If no, that means maximum braking is not required. That means you can go only for electrical braking, E case. Or if it is yes, PBC, that means actual braking power is more than the PM max. In that case, PM max plus PMF have to be used. That is the hybrid braking mode. So this is the braking side, E and F. Let us see what is ABC. So vehicle speed V, whether it is V is less than VER. If yes, that means I am almost in that VEB region. In that case, electric alone traction mode. If no, that means higher speed is there. In that case, we can go for hybrid traction mode. That means higher power required or vehicle speed is too much big. In that case, only the PPS or only the engine cannot supply. In that case, we have to use the hybrid traction mode. That is the B type. In that case, if you are finding that TC stands for traction is greater than PE optional, if no, that means actually we can go for, and this is yes, SOC is less than SOC top. If SOC is less than SOC top, then only we can go for PPS mode. And what is this? PTC is greater than PE op. That means whatever is the traction power required, whether that is greater than engine power. If yes, that means engine alone cannot supply everything. Okay, so in that case we have to go for hybrid mode. That means in that case engine and PPS should be supplying all the power to the vehicle. But if you are finding that required traction power is less than PE, that means PE is actually greater than traction. In that case, we have to see two things: whether SOC is full or SOC is below the top line. If SOC is below the top line, then only we'll go for the mode 3, that is a PPS charging mode. But if SOC is full, at that time we should go only for engine alone traction mode. So whatever 6 modes are given, so this hybrid braking mode is there, and regenerative, these two are the braking mode, and ABCD. So A is engine alone, B is hybrid, C is PPS charging, and B is so A is motor alone, B is hybrid, C is PPS charging, and D is engine alone. So all this is explained with the help of this flow chart. So this also can be asked as a full 10-mark question. Okay, so in this case, what all you have to do is you have to explain all these cases A, B, C, D, E, F. So either you will be asked this diagram, diagram graph of traction power, braking power, and vehicle speed, and you have to explain all this A, B, C, D, E, F with respect to this traction power, and vehicle speed diagram, or the same process with the help of a flow chart. Okay, the same two things was discussed in series hybrid as well. We explained it with the help of a graph, that is a traction power, braking power, and vehicle speed graph, as well as we had explained the same thing with the help of a flowchart. So both can be asked, and actually it's a 10-mark question. So prepare both this question very well. So before you are doing it, you have to understand all the 6 modes. In case of a series hybrid, there were 4 modes. In case of parallel hybrid, there are 6 modes. So these are the 6 modes you have to understand. So in this case, it is said that for a very good braking performance, so this is the thing, for a very good braking performance, the braking forces on the front and rear wheels should be proportional to their normal load on the wheels. So these are some of the conditions. Thus, braking power control will be exactly as regenerative braking. The control flowchart of max SOC PPS is illustrated here. So in this case, the major objective of control strategy is when the vehicle speed is higher than the preset value, engine should be used as the vehicle's primary mover such as possible with no pure electric traction. That means we have to use engine most of the time for driving the vehicle. So PPS should be used as less as possible. But when too much power is asked, at that time engine and PPS both should be used. The control strategy minimizes the part of the engine's energy that cycles through the electric motor and the PPS. This may reduce the engine's energy transmission losses. However, the PPS is fully charged and load on vehicle is small. The engine is throttled down to meet small load power. Here, the engine suffering as the operating efficiency becomes low. So, all these things are explained with the help of this flow chart. And two questions can be asked from this: whether you have to explain all the six modes A, B, C, D, E, F with the previous graph, that is the traction, regenerative brake force, and vehicle speed, or you explain all the six modes by means of a flow chart. So, I would suggest you prepare. Both these questions as a 10-mark question. If you see the question bank, you will be finding both the things are asked. Lastly, we'll go for, so this was the first control action, that was the SOC of PPS control. So two more slides are there which are very easy actually. This we have done in case of series control also. So what we find is initially the PPS is at the bottom line, so this is called as SOC bottom, and whatever power engine is producing, this is doing two parts. So here you can find that engine is on. Okay, so this engine is on. This is called as an engine on off. When the vehicle operates in a state wherein the load power is less than the power that the engine produces at optimal operating efficiency, and the PPS is fully charged. So PPS here is fully charged. In this case, engine will be off. Okay, so in this case, PPS will be charging or PPS will be supplying all the power required for the traction motor. Okay, so whenever the PPS is supplying for the traction motor, in that case engine will be off. So here is a PPS top line, 100% PPS. Here is a PPS bottom line. Generally we take it 70% or 80%. This is a pre-decided thing. So this is PPS of the SOC. So it is saying that when the vehicle operates in a state in which the load power, that is PL, is less than the power that the engine produces at optimal operating efficiency and the PPS is fully charged, the max SOC PPS control strategy forces the engine to operate away from its optimal operating region. That means in this case, engine first charges the PPS to the maximum top line, and after that, engine becomes shut off. Okay, so whenever the PPS is charged up to 100%, then PPS does what? PPS tells engine that okay, you sleep, I will take care. So in that case, the PPS will be charging all the power to the load. That is, it will come down to 70%. As soon as it comes down to 70%, again engine will be started. When the engine started here, engine is doing actually two jobs. Whenever is the engine is on, it is doing two jobs. It is supplying the PL power. So in this case, PE is there. PE is doing two jobs. It is supplying PL as well as it is supplying PPPS. So whenever the engine is on, it is actually charging the PPPS, you can see, and it is actually supplying the PL power. And again, whenever the PPPS goes to its peak, what engine is doing? Engine is again off because it has charged the PPPS. It is like a teacher is producing some students who again is becoming teacher. So when the main teacher is actually teaching some of the students in this path and creating and making them teacher, after that the teacher stops, and this newly grown teachers, they start teaching the younger students. It is same thing like that. So whenever the engine is on, it is doing two things. It is charging the PPS as well as it is supplying the load. When the PPS goes to full charge, again engine becomes off. Again this PPS is charging the or supplying the final traction element, and PPS is falling to 70%. So consequently, the overall efficiency of the vehicle suffer in this situation. The engine on off, so thermostat control. So here there is a thermostat. Thermostat actually controls this on and off of the engine. Okay, the thermostat acts as a sensor kind of a thing. So whenever the PPS is found to be fully charged, in that case thermostat switches off the engine, and whenever the PPS falls to the 70%, thermostat switches on the engine. Okay, so this is what is done. So consequently, the overall efficiency of the vehicle suffers. In this situation, the engine on off is controlled by the thermostat. Whenever the PPS is at 100%, thermostat switches off the engine, and whenever the PPS falls to 70%, thermostat switches on the engine. So engine on-off control or thermostat strategy may be used. Here the operation of the engine is controlled by the SOC of the PPS as shown in the figure. This is the last slide. It says that during the engine on period, the control strategy is max SOC of PPS. So when the engine is on, it tries to take the PPS to max SOC. This top line is the max SOC. Here the engine is always operated on the optimal curve. So engine is not stretched too much. It is working in the optimal part. When the SOC of the PPS reaches its top, so this slide is more about the overall explanation. Previous slide was more about the introduction to this method. So when the SOC of the PPS reaches to its top line, the engine is turned off and turned off by the thermostat action. The engine is turned off and the vehicle is propelled only by electric motor which is supplied by the PPS. When the SOC of the PPS reaches to the bottom line, that means here, okay, in this case engine is turned on again by the thermostat and the control again goes into max SOC of PPS. That means engine again is having the job to charge the SOC to its peak. So this control strategy uses the electric motor as the primary power source. The engine either operates in its optimal region or stops. Thus, the average operating efficiency of the engine is optimized. So whenever the engine is on, it is working in its optimal region, and otherwise engine is off. So in the previous case, in the SOC of the PPS case, that was the 6 modes that we had seen, there many of the times engine was overstretched or many of the time engine was understretched. In this engine on off thermostat control strategy, what we are finding is as long as the engine is functioning, as long as the engine is on, it is functioning only in its optimal region. Very important thing. Optimal region means efficiency of the engine, power production efficiency of the engine is highest. So this is very important thing, that the engine either operates in its optimal region or stops. So in this case, this is the thermostat control strategy. Thus the average operating efficiency of the engine is optimized. Last sentence, however, contrary to the max SOC of PPS control, the engine energy that goes through the electric motor and PPS is also maximized. That means that engine to the PPS link, that efficiency is also maximized in this case. It may cause more energy losses in energy conversion. With this control strategy, electric motor must have sufficient power to meet the vehicle's peak power during the engine's off period. So only one caution is there, that is whenever in this discharge, PPS discharge path, okay, so this is one discharge, this is another discharge. In this discharge paths, PPS charge is continuously reducing. So we have to see that even if the PPS is charged between 70 to 100%, then also the motor is able to supply maximum load which is required by the vehicle. So last line is very important. With this control strategy, electric motor must have sufficient power. Electric motor is being powered by the PPS. That means PPS must have the sufficient power to meet the vehicle's peak power during the engine's off period. Because when the engine is off, even if there is a sudden requirement of power, everything has to be supplied by the PPS or motor only, because engine is off here due to thermostatic action. So only caution is, with this control strategy, electric motor must have sufficient power to meet the vehicle's peak power during the engine's off period. So these are the two control strategies. One is max SOC of PPS and second one is engine on-off thermostat control strategy. These two control strategies are enough for your syllabus. So next day we will start with the design or size design of hybrid vehicle drivetrain. So there are mainly three design parameters. One is motor, another is engine, and another is PPS. So those three topics, if we do, the syllabus of this EHV will be over. We will start with that motor design considerations for hybrid electric drivetrain. We will start with that tomorrow, and tomorrow also lecture will be there at 9:15 to 10:15.